Thank you for the invitation, Matthew, and I think it's great that we actually have such a diversity of speakers. I said I'm from the School of Architecture and Built Environment. I'm in the Faculty of Engineering and work in this area of circularity a lot. I'm actually just curious to understand a few questions before I go. I will be in within 20 minutes. But who of you knows what the Fosbury flop is? Hands up. 1, 2, 3, 4. No one here? The Fosbury flop. Have you heard of the Fosbury flop? Do you mind explaining it?
It's the high jump technique where they like jump over the bar and do the flop. I don't know.
Do the flop, yes. If you don't know the Fosbury flop, I think you have to look it up this afternoon. It's going to be a task. The Fosbury flop was done by a young American high jumper, not that young anymore, called Dick Fosbury, and it was dubbed the flop. Before that, there was the Western roll, the scissor kick, and everybody laughed at him. He didn't have a very good, second name, really didn't help him in all of this. But he was laughed because it was really weird. That's not how he do it. That's not how we do a high jump. There are really clear practices how to do this. And then it was a key event. When everything changed for him? He won the gold medal in the 1978 Olympics in Mexico City. And since then, everybody does the Fosbury flop. And it was built on previous techniques, and it set a new standard. And I personally think that standards change. I think it's super important that we are conscious of this. They also build on other practices. But in my discipline, architecture, the bar is rising. There's more and more constraints and expectations on buildings. We need to build more with less. Budgets are smaller, timeframes get smaller, and we need to think about how to get over this bar. And I think we need to do this as a society. Yeah. The other question I have is, who of you knows what is more important? What is embodied energy? Does anybody know what that is? Embodied energy. Anybody in the room? Nobody in the room. Yeah.
The energy that was used to build the particular construction or the carbon that was built for it.
So it's all the energy, all the carbon that is used from the extraction of the raw material, the transport of that material, making that product, all the way to the end of life of the disposal. And it's different to, what's the opposite of, or not opposite, what's different? So embodied energy is a one-off cost. And the other thing is called operational energy. Yeah? And do you know what operational energy is? The energy used to keep the lights on, run the air conditioning, all these things. So we're at a time where operational energy, because we're talking about just energy transition, we're getting a handle on this. We're, yes, there's a long way to go through green energy, but embodied energy is not coming down. And this is where we work within the built environment, yeah, which is very, very important. So, of course, I would like to acknowledge the traditional owners. And the work that I'm showing you, is done in collaboration. It's also not just done at QUT. I had previous lives at different institutions before. I would like to acknowledge them as the traditional owners of where we are, QUT, and pay my respect to their elders, laws, and custom and creation spirits, and recognize these lands have always been place of teaching, research and learning, and as you said, caring for country. And we have, I think, a very strong framework here, also at QUT. It's a core practice, and I think there's a lot that we can learn from our Indigenous and First Nations community. Now, there's a huge ecological challenge, certainly in my discipline. We are a very resource-hungry discipline. It's always shocking to tell this to a first-year architecture students. Basically, you're entering a professional life where you are one of the biggest contributors to global greenhouse gas emissions, the destruction of, diversity in nature, and so on. So they all get a bit, pale at that moment. We use a lot of energy, we produce a lot of waste. At the same time, we have an enormous economic relevance, also in Australia. And we have a very big social cultural importance as well. Buildings actually have a critical role. We spend a lot of time in them. And I personally think, even though there's a lot of research in technology, it is not a technological problem. The problem is us. Sorry, Matthew, this is not a critique of you, but this is the problem. How many of you got a free coffee before? How many of you asked for no lid? I have 2 children. Every Christmas we do an exercise when we're younger and just save how much plastic we have after Christmas. And it's shocking. It's actually very hard to navigate this space, I think, as a society and try to reduce your own waste. And I think it's actually us. And we all, of course, you won't save the world by not buying a coffee. Yes. But we all have agency. And I think it's very, very important that we're conscious of that and every day we make the right decision in that. So, there's some really, really hard facts. Because it's such a big discipline, you could say, well, it is also one of the biggest opportunities that we have. The built environment is so big that while it contributes, if we change things here, we have a tremendous impact, on our society. The other question is, who of you, we're talking about circularity, yeah? How many R's are in the circularity framework? There's different ones, but tell me what's the highest value R that we should achieve as a society? Or what's the lowest one? The highest is?
Reduce.
No. No. What's the lowest one? What are we currently doing?
It's wasting everything.
Well, we're wasting here, but there's, for example, a 9R framework. The lowest R is we're burning it. We're recovering the energy. Well, we're actually just burning it. The second lowest one is what everybody is so excited about, recycling. It's the second last resort we should be doing. The second last. There are 7 others. The very highest one is to refuse, to rethink our practices, our behaviors. It's to refuse, yeah? So what I'm going to show you is a few projects that we're doing and have been done which look at these things. And from the built environment, because it's so big, there's absolutely no credible path, as was done by Inges Andersen, to address climate change without a fundamental shift in the building sector. And we are at this point, where we are in this situation and there's no way that we can deal with this without actually dealing with the physicality of the built environment. Now, there are a few things that are exciting. I think in Australia, for me, I think it's the first time, Matthew and others will prove me wrong, but I can see a government document that identifies the built environment as one of the 4 key sectors to help us double our circularity. And one of the key enablers, and this is what I'm very excited about because I'm very passionate about design, is design. Design has been identified in a federal government document about helping us change the future. Now that is exciting for anybody who's passionate about design. There's the Australian Reduction Roadmap, a kind of key report that I put together with colleagues from the University of Melbourne and UTS, and I will talk about this project a bit more. And within my own discipline, the Institute or the Australian Institute of Architects has also an architecture industry decarbonization plan, which came out in 2025. Now, just quickly, the Australian Reduction Roadmap is based on the Danish Reduction Roadmap. So we have very strong connections to Denmark, and they, if you think about it, they have 3 more of these. So it's beyond the roadmap. And as an entire building community, like an entire sector, actually put out and said they refuse to build. Of course, they still need jobs, they still have practices to run, but their biggest thing was that they refused. They put so much pressure, they came together and put pressure on the government to change the buildings legislation, to change the Building Act, yeah? And this is, I think, what we need to do here. So what we did, and you all would be familiar with, our planetary boundaries, I won't go into this, but to stay within those, then a very, very quick calculation. This is what we have, this is our global annual emissions. In order to stay within a safe operating space, we need to go to this. That means for us, that was in Denmark, they were a bit ahead of us. If this is how much carbon budget we have, well, we can stretch it, we slice it, it's very linear. We can maybe stretch it to 2031. So we started at this, we looked at the Australian context. This is the global carbon emissions. This is the limit. In Australia, we have that currently as our national emissions target. And this is our limit that we need to get to. It's a lot smaller, isn't it? And it's not just a numbers game. Things really start to change if we don't do this. And these are not just abstract numbers, 1.5, 1.72. It's not just, things really have an impact for us, all of us. So we did this for Australia. We thought, okay, what is the actual budget that we have in Australia? Of course, there's different scenarios one can play with that have different ramifications on us. And we said, okay, well, let's play through those different scenarios in order to see what would happen or what could happen. And we used the Australian housing target as our case study, basically. I mean, the government said we're going to build so many new houses. If we would do this, we would exceed our carbon budget by 300%. No more lights, nothing else will happen if we would try to build all those houses. Nothing else can start. No, there's more power, yeah. I'll be there, trust me. So to look at our housing industry emissions and our limits, it's a dramatic change that we need to do, yeah? So this has become a document that now in Australia, lots of architectural practices and builders have signed up for, and we're working collectively on trying to do the next one. And of course, there's many different scenarios. If you think about how we build 2 big houses, our houses actually increased. We can very, very different typologies of houses rather than building these kind of 200 small units. We could also build other units, for example, densification and things like that. You can look this up. I just want to let you know that we cannot achieve the targets that have been set by the government if you continue building as usual as well. So we need to change our behaviors. There's lots of different ways. I'm quickly going to show you, bless you, one project that we did, which has been patented, where we looked at the retrofitting of existing building stock. So in here at the moment, this is called a swirl diffuser. They are one of the biggest complaints of tenants. In German, I'm German, I suppose, like es zieht, you get this kind of breeze on your neck. My mother always complained about this. But the building surfaces are not staying up to date with the changes of our building use. These were designed for a very, very different layout, for mostly a male working force. All these thermal comfort regulation standards have been set for that. And what we did is we had a look, okay, how can we maybe reduce this, and asked a lot of very naive questions and worked with engineers in order to reduce the carbon footprint of that. Because if you think about the building, 30% of all carbon is actually in the building surfaces. So you would do all the great things with the design, with the materials, would all be great, and then in the end you get some really outdated building services in there, and your entire energy household, what you try to do really, really well to reduce the carbon footprint of that project goes out the window because of outdated services. So we developed this 3D printed ducting. This is usually what it looks like. Underneath here, that's what you see. There's so much carbon in these building materials, and we thought about just very basically how could we breathe new air literally into those building services. And we didn't look at all of them. There's a very, very narrow, agency that we have. We really just looked what is within a floor plate and spoke to manufacturers. And what's amazing about this is that these are very leaky systems, but if they're installed, if they're moved from a manufacturing plant, this is very, very fast with advanced manufacturing, they move a lot of air. And the kind of carbon that is associated with even just the logistics of the ducting units is absolutely enormous. And they've been designed for a manufacturing process. So this is folding the steel in rectangular sections or sometimes round, and then they have 90-degree or 45-degree angles when they need to move around, but that's not how air moves. So we looked at advanced manufacturing, 3D printing, you mentioned it, in order to design a new ducting system that actually is designed for optimal airflow, which reduces the size of it and really reduces the carbon footprint of that as well. And I'm just going to flick through this in order to show you some of those images of that, because you also think it looks quite beautiful. And then I'll leave you with a small little video. So we did a lot of analysis, so we work a lot on digital tools in order to help our sector, our profession, to make the right choices in design, but also in the manufacturing process, using, for example, advanced robotics. So rather than having something like this, thinking about, how can we get some inspiration from other sources where we actually have a leaking system that is distributing air evenly rather than dumping air on us. And we used reclaimed or recycled plastic, PETG. That was during COVID, where a lot of PETG came on the market because all of those medical devices were packaged in those as well. On that, I hope you all look up what the Fosbury flop is. That you become very conscious actually about the energy household. I think it's super important. I remember as a kid walking with my father on the weekends to recycle the glass. There was the brown, the clear, and the green glass. And I think we here in Australia are still quite behind if you think about how we deal with our waste. And we're not very conscious of that. And I think as a society, we have a really, really great opportunity. And I think we're all agents of change. And that's what we do certainly within our research group and also at QUT. So thank you.